Hello, calculus fans. Okay, so let's compute f prime of x given this function, f of x equals 4x cubed minus 5x. So we're going to use the definition of the derivative function. And that means we're going to have to write this as a limit. And it's the usual limit that we've been working on. So let's go ahead and plug in the function into this. So we get the limit as h goes to 0 of 4 times x plus h cubed minus 5x plus h. So that piece of it, this here, comes from plugging x plus h into the given function. And then we have to subtract off f of x, which is this piece here. Okay, so now let's work on simplifying everything. All right, so when we multiply out the x plus h cubed, we get this expression here. And then we'll work on everything else in a moment. Then if we distribute everything, like the 4 and the minus signs, then we get this expression. And then what we really want to do is do a bunch of canceling. So let's see what we've got that can cancel. So for instance, we've got 4x cubed and 4x cubed that cancel. We've got the 5x that cancels. And let's see, looks like that's about it, so we're going to work with this. So after we collect everything, then we get this expression. Remember what our goal is. We're going to try to factor out an h because what we really want to do is cancel out this h in the bottom. So this theme has been recurring. So we factor out that h, and then we're going to cancel. Now that we've canceled, we can go ahead and plug in h equals 0 because we're going to use the direct substitution property. We think of h as being the variable in the limit. Everything else is just a number, so the thing that you have here in parentheses is a polynomial function, and so it's okay to just plug in h equals 0. Once we do that, we get our final answer. So this is what we're looking for. Now what I'd like to do is think a little bit about the interpretation of this answer. So what this is saying is that the slope of the tangent line to the curve that's defined by fx equals 4x cubed minus 5x at the point x comma f of x is this value here. Now this limit exists for all x, right? It didn't matter what x was, the limit existed. So the domain of f prime is the set of all real numbers. Okay? Now let's continue on a little bit talking about the interpretation. Let's suppose somebody asked us, what is the slope of the tangent line to y equals 4x cubed minus 5x at the point where x is equal to 3? Well, we know what to do with that. We evaluate a limit. This is the limit that you would evaluate. We've seen this many times. But now that we've calculated the derivative, we can just bypass this. Now that we have this expression for the derivative, if somebody asked us what is the slope of the tangent line to the curve where x is equal to 3, well, what we do is we simply plug in 3 into the derivative, and whatever number we get, that's our answer for the slope. So essentially the idea is that the calculation of the limit that we had done earlier to get the derivative will give us the slope of the tangent line anywhere that we're interested. It's sort of an all-in-one proposition. Okay, that's all for now.